Dr. Shweta, you can start introduction.
Okay, sir. Thank you, sir. Very good morning to everyone. Myself, Dr. Shweta Sachan, working as an assistant professor in the Department of Livestock Farm Complex, Duvasu, Mathura. I would like to express my gratitude to National Agriculture Development Cooperative Limited, Baramulla, Jammu and Kashmir, and organizing committee, Duvasu, Mathura, of 21 days winter school on recent advances in agroecology, compasture, and forest research for doubling crop and livestock production, for nominating me to introduce our today's guest speaker, Dr. Shalini Vaswani. She is working as an assistant professor in the Department of Animal Nutrition, Duvasu, Mathura. It's my pleasure to welcome and introduce you, ma'am.
Thank you, dear.
Dr. Shalini Vaswani obtained the degree of BVSc and AH with Chancellor Gold Medal from NDUAT, Kumarganj, Ayodhya. She did her post-graduation in discipline of animal nutrition and received B.N. Gupta Memorial Award for academic excellence from NDRI Karnal in year 2007. Thereafter, she started her professional career as a veterinary officer in UP state government in the year 2007. After serving in field of for 3 years, she pursued her PhD from Duvasu, Mathura. Then, in January 2014, she joined as assistant nutritionist in Department of Animal Nutrition, Gardasu, Ludhiana. Later, she joined as an assistant professor at Duvasu, Mathura. She received scholarship from BLIR UOS by the Belgian federal government for international training program in dairy nutrition at Ghent University, Belgium in the year 2015. She had successfully established silage unit, feed analytical laboratory equipped with recent and advanced instrument for analysis, mineral mixture and fodder block unit and pellet feed plant at university under RKVY funded project at principal investigator. She had successfully handled projects of more than 8 crore funded by external agencies as a principal investigator and co-principal investigator. During her career of 8 years as an assistant professor, she efficiently teaching related to animal nutrition to undergraduate and postgraduate students. She had published 6 books, 40 international and national research articles, 3 review articles, delivered 3 lead papers and assisted 16 students as a guide and co-guide and research committee member. She is a life member of various professional societies and presently serving as an editor of Indian Journal of Animal Nutrition and official journal of the Animal Nutrition Society. Also, she had successfully conducted ICAR sponsored winter school as a course coordinator, organizing secretary and course coordinator of more than 19 training programs for veterinary officers, rural youth and farmers across the country. She also completed 3-month international training program at University of Florida, Florida, USA under IDP NAHEP. She is recipient of several awards and recognitions from the international and national organization. And now, I hope that we are overwhelmed us with your knowledge and experiences with this topic, silage making an emerging enterprise for dairy sector. Please, ma'am, start. Thank you, ma'am.
Thank you so much, dear Shweta, for introducing me to the participants. And can I now start the presentation?
Yes,
You are
ma'am,
audible as
please.
well as visible. Presentation
Okay,
is
okay,
also visible.
okay. Thank you so much. And very good morning to all the participants. Today, I'm here to present a talk on the topic that is a silage making an emerging enterprise for dairy sector. So before getting into the actual mode of the topic, I just want to make you all clear that what this silage terminology means and what is the current status of the silage here. So let's carry on with this. As you all know that basically we are feeding the animals with the green fodder, dry fodder that comprises a part of the roughage, and the other major part is the concentrate. And in the roughage portion, the green fodder is the major component, you can say. And the dry roughage, basically it is having a very low nutritional profile, but we are feeding it to the animals just to balance the rumen status and the rumen environment. But this green fodder, this is having a very specific place in the diet or a ration of the dairy animals specifically. So why this green fodder? Because it is very palatable. It is having a compact pack of nutrients also that comprises both the macro as well as the micronutrients. This is easily digestible, and the rumen ecology and the rumen microbes are well efficient to digest this green fodder and to make energy from this. And of course, the most important part is that this is the cheapest source of the nutrients which is available to the animal. So because of its cheap prices, because of its easily digestible characteristics, because of its high nutrient content and palatability, this green fodder is the major portion of the livestock ration. Understood? So how much amount of the green fodder is required to a particular animal? That because we know that it depends upon the status of the milk production. It depends upon the physiological state of the animal, that how much green fodder we are going to give to the animal. On an average range, I can tell you that if it is an adult animal and it is kept on the maintenance requirement, and at that time we need to feed the animal with about 10 to 15 kgs of the green fodders along with the dry roughages and the concentrate. But just now we have discussed that green fodder is the major component of the ruminant's diet. It is having a very chief characteristics, very good nutritional profile. But on the other part, if we see the scenario of the availability of the green fodder in the country, we can see that the country is facing a serious deficit as regard to the green fodder. So now we are clear with the two things, that we require the green fodder as a diet, as a pack of a nutrient for the animals, and it is easily acceptable by the animal, very palatable. But on the other hand, we can say that it is the availability of the green fodder is decreasing day by day. So now where comes this silage terminology? Silage is actually the conserved green fodder. It is a replacement of the green fodder. So basically, initially when this concept came in fashion, at that time we were saying that we will be feeding the silage to cope up the lean season. What is this lean season? That it means that in our tropical conditions, the country is having the tropical climatic conditions. So at this time, what happens that we do not have a throughout supply of the green fodder during all the months. So there are specifically two seasons basically at the start of the summer, that is nearly April to May, and here in October to November we are having the deficit of the green fodder. Rest all the time we had the green fodder as per our climatic conditions and the agronomical conditions. So to feed the animal during that season, we require the silage. This was the very first concept that we were having in the mind, that we should conserve the green fodder when we are having ample amount of it, when we had the extra amount of the green fodder, specifically during the monsoon time. And then if we are conserving this green fodder, and then we can, conserved green fodder in the terms of silage is available for the animals to be fed during the lean season. Other utility was that why silage is required? To reduce the qualitative and the quantitative fluctuations in the forage supply. As I already told you, that the supply of the green fodder is not continuous. The quality decreases as it matures, the lignin content increases, fiber content increases, and the nutrients content reduces. And the quantity also is also not, we do not have the continuous supply of the nutrients, supply of the green fodder throughout the year. So to manage that, we need silage. We need to conserve the amount which we are having some extra during the monsoon time. The other one is to supply the diet of the similar composition throughout. That means when I will also show you this thing, I will explain this thing by giving you one example through the slide. Then we will discuss it more. For economic feeding of the livestock. For economic feeding, I told you, because green fodder is prepared from the silage is prepared from the green fodder, and green fodder is the cheapest source of the nutrient. So, of course, this silage will be economical to feed the livestock. To enhance the nutritive value of the feeds. Sometimes what happens when there is a reduced availability of the green fodder, at that time, there are two options left with the farmers, that either they should increase the amount of the dry roughages, or they can increase the amount of the concentrate to cope up the deficit amount of the green fodder. Basically, our farmers are quite poor. They cannot afford much of the concentrate, so they increase the dry fodder in the diet of the animal. So again, if we are, as we already discussed, that this dry fodder, the nutrition value of the dry fodder is comparatively very less as compared to the green fodders. So if we had some options, some alternate as which is at par to the green fodder, then of course the nutritive value of the diet which we are feeding to the animals will be increased. Next, for efficient use of the extra or the surplus fodder during the rainy season. At the time of rainy season, we had some extra supply of the green fodders, green grasses. So sometimes if it is not utilized, it goes waste. So to conserve that waste, we can shift the extra amount to the silage making. To reduce the content of the anti-nutritional factors, because every feed, in fact, or every green fodder is having some of the anti-nutrients. So sometimes when these anti-nutrients, they are present more in amount, they had some of the health and the production deleterious effect on the health and the production of the livestock. So but if we are going to ensile this green fodder, if we are going to prepare the silage of this green fodder, because it comprises of the anaerobic fermentation. So during this process of the ensiling, the amount of these anti-nutritional factors, this also reduces. To maintain the ruminal environment, because the rumen environment, because you know that this rumen, this consists of the thousands and the millions of the microbes. So for the efficient working of these microbes, the ruminal environment should be conducive to them. So when there is a quite deeper fluctuations in the pH, at that time the health of those microbes is in the question. So we presently concept is that we are not feeding the host, we are feeding the microbes. So for the proper digestibility, to efficiently utilize the nutrients, to efficiently utilize the feed, we need the proper environment of the rumen, which is maintained by silage feeding, because it consists of a similar composition, and the similar composition of the feed is fed throughout the year. So definitely the ruminal environment will not be fluctuating. In order to discourage the daily cut and carry system, because we know that when we are growing the green fodders in the field, we need to harvest them, and then carry to the livestock shed to feed to the animals. And for doing this, we need some extra labors and all. So this practice of daily cut and carry system can be discouraged, because the labors, availability of the labor is also in question these days. There is a lesser infestation of the worms as compared to the pasture. Sometimes during the rainy season, you are better knowing that many of the green fodders, they are loaded with these parasitic eggs and all. So at that time, when the animal is consuming those feeds, those green fodder, at that time these parasites are also coming inside the body, and then there is a parasitic infestation in the livestock. So when we are conserving this green fodder in the form of a silage, during this ensiling process, again, because of the fermentation, the content of these parasites, or the life cycle of these parasitic eggs and all, this disrupts, and again this lead to the lesser infestation of the parasites when we are ensiling the fodder. And of course, because we are harvesting the crop at a particular period of a time of the life cycle of the crop at which the content of the nutrient is at the max. So it usually it reaches, for example, if we are taking the maize, so at that at the nearly 50 to 55 days we need to harvest the whole crop at that time when the nutrient contents are its maximum. And then within 2 3 days, when if we are able to harvest the whole crop, our field is again available to be utilized for the next crop. So from the same piece of a land, we can have a next round of the crop. So these are the some of the basic, we can say, the advantages of the silage making, apart that it is being used to feed the animals in the place of the green fodder during the lean season. So it is also maintaining the ruminal environment. It is enhancing the nutritive value of the feed. It is reducing the contents of the anti-nutritional factors. It is maintaining the ruminal environment, and there is a lesser infestation of the parasites. Along with that, the land or the field is spared for to be utilized for the next crop of the fodder or cash crops, whatever it can be. So, like we have discussed in the last slide, that to reduce the qualitative and the quantitative fluctuations in the forest supply, this I will be explaining through this slide. As you know, during the traditional feeding, we are feeding the animals with the greens, with the dry and the concentrate mixture. So, if we are starting this feeding from the January to April, you can see that during the January, we are having an ample amount of the barseem available with us, barseem and as well as the oat. So we are feeding the animals with the 20 let's take this example, that we are feeding the 20 kg of the barseem or oat, and the 3 to 4 kg of the straw and 4 kg of the concentrate mixture. And for the silage feeding, so this, in the place of the greens, we are feeding the silage, and rest the dry and the concentrate mixture are as constant. So for the silage, we have fixed this 15 kg of the silage we are feeding it to the animals, and 2 kgs of the dry refuges, and concentrate mixture 3 kg. So here, when the month of the February comes, for the silage feeding, we had the similar composition, similar feed, and similar amount. The quality and the quantity of the silage and the other feed are same. But with this, we are also having in the February, we are having enough of the barseem and the oat. So again, 20 kg is being supplied, and the straw 3 to 4 kg and 4 kgs of the concentrate. But in the March, as we know that the barseem availability is very less, and if it is available, then also it is having the high content of the lignin, or the fiber content is high, leading it to the lesser quality, nutritional quality. So at that time, due to the lesser availability, we are feeding the animal with the 10 kgs of the barseem. So to compensate this 10 kg of the fodder, we increased 1 kg of the concentrate and nearly 1 kg of the dry refuges or the straw. So you can see, when we are feeding the silage, the composition was kept similar. But here, to compensate the deficit of the green fodder, we filled the values with the straw as well as a concentrate mixture. And in the April again, the availability is less, and the Napier is available at that time. So you can see we have increased the quantities of the dry and the concentrate mixture. Whereas in the silage feeding, the composition was kept similar. And here, what is happening, if we are increasing the 1 kg of the concentrate mixture in the diet of the animal, it is also leading the cost problem, because 1 kg of the concentrate mixture is nearly 24 rupees or 25 rupees per kg. So we can analyze that the cost, the margins decreases, and the cost of the production increases. Now, we also discussed that we have seen the effect of silage or the ensiling on the anti-nutritional factors. We discussed that when we are going to ensile the green fodder, at that time, the quantities of these anti-nutritional factors which are present in the green fodder decreases. So we can see this example, that we had some of the anti-nutritional factors like nitrates, oxalate in the bajra, and prussic acid in the chari. So these, when we are, if we can see the quantity of these anti-nutritional factor. When in the green fodder, we can see this one. And but when we are going to ensile this green fodder, you can see in the slide that the concentration of the nitrate is reduced by 23%, concentration of oxalate is reduced by 62%, and the concentration of the prussic acid is reduced to 100%. So in this way, we can see that the ensiling also help in reducing the quantities of the anti-nutritional factors, which are usually limiting the production and disrupting the health of the livestock. So now the question can arise in your mind that if we are ensiling the green fodder, or we are converting the green fodder to the silage, so how much is the loss of the nutritional composition? Or we can say that the both silage or the green fodder are at par as per their nutrient composition. Let's see in this slide. You know that the green fodder is having the more content of the moisture, whereas the silages, they have the lesser content of the moisture, and the dry matter, because the dry matter content of the moisture is kept usually at the 30 to 35%. And you can see the protein content is also higher in the case of the silage. Fat content is also higher. Fiber content is also higher, but there is a reduction in the lignin quantity. And you can see the total digestible nutrient, that the energy content is higher with the silage, because this is a fermented one and it is yielding high energy. Whereas the quantities of the minerals, there are more or optimum in the case of the green fodder as compared to the corn silage. The toxins, they are, of course, these toxin and the anti-nutritional factors, they are present in the green fodder. But when we are ensiling it, the quantities of these toxins, they reduce, or these anti-nutritional factors, they reduce. Buffering action, because this silage is having a constant effect on the pH. That means the pH fluctuation is rarely occurs when we are feeding the silage, because we are giving a similar composition of the feed throughout. So there is we can say that there are lesser fluctuations, and the ruminal environment is more or less stable. And the diet composition variation or the variability is reduced when we are feeding the silage. So we can see that the nutrition profile of a green fodder and the silage, we can assume that at least this silage is not, you cannot say that it is less than the green fodder, but you can imagine that at least 80 or 85% of the nutrients are conserved when we are preparing the silage out of that green fodders. And of course, they are also at par to the green fodders. So let's understand what this silage is. Till now, we have discussed that the basic diet, what is the significance of feeding this green fodder to the animals, and then why we are shifting towards the silage, what are the added advantages of feeding the silage. And now we are coming to the basic question that what this silage is. Actually, this silage is a fermented feed which results from storing the high moisture crops during the anaerobic conditions. So there are two terms that we need to have: the anaerobic conditions, and the high moisture crops are these fodder crops. They are stored in the anaerobic conditions in which there is a fermentation taking place. So it is a green succulent roughages which are conserved mostly in its original condition, with very less loss in the nutritional profile. Anaerobically fermented green fodder conserved with the moisture content. I told you that there is a 30 to 35% of the dry matter available with the silage. So this is the moisture content of that. And when this green fodder, it is harvested at a proper stage, is stored, it is packed, and it is compressed in a silo. Silo is a container in which we are going to prepare the silage, and then it is tightly covered to prevent any contact of the fresh air or the intrusion of the water. So this will convert, this green fodder is going to convert to the silage. The process of converting the green fodder to the silage is termed as ensiling. So ensiling is a process by which the fodder is stored in a silo in order to convert into the silage, which is a very succulent feed for the livestock. Is this clear?
Yes, yes, it's okay.
Okay. So we have understood what silage is, and we have seen what is this silo is, and what is the process of ensiling. So coming, what is the principle behind this ensiling? Here it involves the conversion of the water soluble carbohydrates. The water soluble carbohydrates that are present in the green folders, they are converted into the organic acids, and among these organic acids, it is the mainly lactic acid. And this conversion of the water soluble carbohydrates to the organic acid, that is mainly the lactic acid, it is occurred by the lactic acid bacteria under the anaerobic environment to rapidly, so that when there is a production of lactic acid, so what happens, that there is a reduction in the silage pH that will inhibit the organisms or the microbes that are responsible for its spoilage or for the decomposition of the nutrients. So the basic principle is that the conversion of the water soluble carbohydrates to the lactic acid by the lactic acid bacteria under the strictly anaerobic conditions. So what can be the crops which can be utilized for the silage making, and what is the characteristics of those crops which are required for the ensiling? So we have discussed in the principle that there is a conversion of the water soluble carbohydrates to the lactic acid. So definitely those crops which we are utilizing for the silage making should have the high content of the water soluble carbohydrates, because this water soluble carbohydrates is essentially required for the production of the lactic acid. And these soluble sugars, which are, that the content of these soluble sugars are more in the cereal fodders. These cereal fodders like maize, bajra, sorghum, these all contains a good quantity of the soluble sugar, or you can say the water soluble carbohydrates. But on the other hand, these leguminous fodders like berseem, lucerne, they do not have the high content of the sugars because they are rich in the protein. So they are the leguminous one. So they are not the better substrate for the silage making, because we need the soluble sugar to be converted to the lactic acid. So we need the fodders in which there is a high content of the soluble sugars. If there is a non-availability of the sugars, of course, their fermentation process will delay, or it will result in the higher losses of the fermentation. So sometimes, if we had some quantity of the leguminous also, so and we want to utilize that as a substrate of the silage making, so we can mix those leguminous one with the cereal fodders to utilize as a substrate for the silage making. But essentially we can say the cereal fodders which are having the high content of the water soluble carbohydrates or the readily available carbohydrate source are the very good substrate for the silage making. And what should be the dry matter in these green fodders, in these cereal fodders for the silage making? Because we know that if there is a high moisture content, and if we are going for the for storing that high moisture crop, it will lead to the various effluent losses, and that will lead to the loss of the nutrients. And low moisture crops, and but if on the other hand, if we are having a moisture crops that are having a low moisture content, they have the low microbial activity. And you know that these microbial activity is required for the anaerobic fermentation to occur, to convert this water soluble carbohydrates into the lactic acid. So for the better efficiency of these microbes, especially the lactic acid bacteria, we need some optimum amount of the moisture. So either high moisture crops or the low moisture crops, they are not utilized as a better substrate for the silage making. So the optimum fermentation to occur, dry matter should vary between 30 to 50% of the total. And again, we can say that the dry matter can be adjusted by wilting, or by adding some of the absorbents, or by mixing some dry roughages, or because again they will be also a good source of the absorbents. So now we have seen what should be the characteristics of the crops which are required for the silage making. What should be the amount of the water soluble carbohydrates and the specifically the dry matter and the moisture content of those water crops. So now we are coming to this ensiling process. This depends upon, of course, the moisture content, the amount of the lactic acid bacteria, that means the number of the lactic acid bacteria, because these are the one which are going to convert this water soluble carbohydrate present in the cereal fodders to the lactic acid. So the number of the lactic acid bacteria, the count, there is a positive correlation between the number of the bacteria present at the time of the ensiling and the rate of the pH decline. The pH will decline when there is a higher production of the lactic acid. And similarly, when the pH will decline, the microbes responsible for its decomposition, for its spoilage, for the loss of the nutrients, their growth or their population will reduce because of the reduced pH conditions. And again, we need the water soluble carbohydrates, and we need the low buffering capacity. You know what the buffer is? Buffers are the one which resist the change in the pH. Here we want to change the pH towards the acidic as soon as possible. So we don't want any substrate which is having the quality of the high buffering capacity. So if their capacity or if their buffering capacity will be high, so the change in the pH will be less. So we need those crops which have the low buffering capacity. Like leguminous crops, they have the high buffering capacity. And we have already discussed that these leguminous crops, they are not an ideal substrate for the ensiling because of their high buffering capacity, because of their low content of the soluble sugars and the high moisture content. Because of these three characteristics, these leguminous crops, although they are having a very high content of the proteins and are very palatable, still they are not serving as a good source of the substrate for the silage making. And if they are ensiled, suppose if you again still you are ensiling it, the acid production will be very less. There will be so much degradation of the proteins, and there will be the high production of the ammonia. So for a rapid and extensive fermentation to occur, because extensive fermentation will lead to the conversion of the water soluble carbohydrates to the lactic acid. So if we want a rapid and extensive fermentation to occur, the forages must have the high concentrations of the water soluble carbohydrates or the fermentable carbohydrates. And for example, maize, sorghum, bajra, those cereal fodders, they are the best utilized for the silage making. They should have the low buffering capacity so as to do not resist the change in the pH. And the dry matter content should be nearly 30 to 40%. There should be low levels of the proteins and the minerals, and there should be the adequate number of the lactic acid bacteria. So most important crops for ensilings are usually, of course, they are the cereal fodders, but among those cereal fodders also, the whole crop maize is the best source or the best substrate for the ensiling. So what are the crops which we use for the silage making? We have already discussed the characteristics of the crops which are utilized for the silage making, and of course these are the cereal fodders. But when you are these are the technical terms, that they should have a high content of the water soluble carbohydrates. They should have the low buffering capacity. They should have an adequate amount of the lactic acid bacteria. But when you are telling this to a farmer, you should tell them that the crops that have the thick and a solid stem and that are rich in the carbohydrate content, like the cereal fodders, they are the best for the silage preparation. And we have already discussed that this silage, it is going to be prepared in a container or in a structure or in a receptacle in which we are going to ensile that green fodder. So this is called as silo. It can be a container, it can be a jute bag, it can be a trench, it can be a pit, bunker, whatever we had, depending upon the amount of the green fodder available to us for ensiling. So we will decide the dimension as per the our criteria. We decide which type of silo we are going to utilize and what should be the standard dimensions of that silo. So there are different types of silo we discussed, like it can be a pit, it can be a tower, it can be a trench or a bunker, and sometimes these all are permanent structures for the silage making. These are the permanent silos, but sometimes there are temporary silos also, that we are converting any plastic container into a silo, or we are using some polythene bags or the jute bags that can be utilized as a silo for the silage preparation. So basically these types of silo, they can be permanent and the temporary both. And how to decide that which type of a silo you require for the silage making? It depends that if you had, suppose you had two animals, and will it be justified to develop a pit for them, for just feeding the two animals? So definitely, how many number of animals you are having to feed the silage, this and the how much length of the time, what is the duration of the period you want to feed the silage, because there are the different purpose or the targets of the farmers, that sometimes they want the fodder, they want the silage only for the two period when there is a lean season. Sometimes there are the other one which want that they should at least have the silage for the 6 months period. So it depends how much length or the duration of the time you want the animal to feed upon the silage. That also decide your silo length and the dimensions. Which kind of a soil is available, how is the drainage facility, what is the depth of the water table. If the underground water table is not is at the higher level, so definitely this here the silo pit will be not worth to make it, because the quality of the silage will not be good, because there will always be a seepage of some amount of the water in these pits. What is the rainfall and the other the weather conditions? So these are the things, that how much animals you are having, to which length of time you want to feed the animals, how much amount of the green fodder is available to you, that you require to convert it to the silage. What is the status of the water table, which type of a soil you are having, what is the climatic condition of that region. This all decides at which type of a silo is suited at your conditions. So here you can see these are the jumbo bags which are also available at the certain online sites. In this, the outer covering is of the jute and the inner covering is of the polythene. These are again the silo packs which we are making with the silo pack machine. These are the plastic containers which we are using making the silage. These are the pits. This is the bunker which we are having. And this is the last one, the latest one. These we called as a bales of the silage, which is prepared by utilizing the silage balers. This is the new technology. So this we have discussed what silage is, what is ensiling, what should be the criteria for selecting the silo. We have seen the pictures of different type of silos, and now we are coming that we have decided that which types of crops are suitable for silage making. Now we need to know at which time we should harvest this crop to get the maximum amount of the nutrients, so as to retain the maximum concentration of the nutrients, so that the green fodder is converted to the silage in its best form. So what should be the stage of harvesting? So for the stage of the harvesting differs as per different crops. Like as in maize, we harvest it at nearly 50 to 60 days. I will also show you the details of how to assess the milk line, and how to see whether these cobs, these grains have reached the silage stage or not. I will show you in the further slides. In the sorghum, we need nearly about 75 to 90 days to harvest this crop for the silage making. For the bajra, it is 45 to 55 days. For oat, it is little lengthy, 90 to 115 days. And for the other napier, guinea grass, sugar grass, it depends upon like that. For the napier, we can see that up to the grass is about 1 meter of the height. We can see when we see about the for specifically for the maize, these are the stages of the cobs. This is the milk stage, this is the dough stage, and milk. So this is the proper stage when we require. We should cut the silage for the. We should cut the green fodder of the maize for the silage making. So I will tell you in this slide that we need to see the milk line. So this one is the milky stage, and in this when the stage is milky dough, you can see this is the milk line which start coming to grow down towards the kernel, towards the grain. So in the other one is the dough milky, you can see the milk line has gone little more down. And in the dough stage, when you can see that the milk line has gone 1/3 way down the grain, down the kernel. So you can see the yellowing of this part. And at that time, the dry matter content is nearly 30 to 32% of the whole plant. And when it is sometimes, if it is halfway down, so you can see at this time, the dry matter content is 30 to 35% of the whole plant. So this is the best stage. This is the best time we need to harvest the maize crops for converting it to the silage. That is when the milk line is 1/3 or halfway down the grains, and the dry matter content of the whole plant is nearly 30 to 35%. So this is the time usually this arises at nearly 50 to 60 days of the age. So maize is best suited to be ensiled when the grains are in the milking stage or at 2.5 milk line score. That is, the milk line is halfway down the grain, and this stage is considered the best stage to harvest the maize for silage making. The other method to determine the dry matter content, because we had the ovens in our laboratories, we can check we had the moisturometers and all, we can check and assess the amount of the moisture content or the dry matter content in the fodders, in the crops. But for this one, for telling to the farmers, it is difficult. Sometimes they need to understand in a more easy way to how to understand that which is the best stage to prepare the silage. So for this, you can tell them the grab or the fist method. And what happens, nearly at 50 to 60 days of the time, you can advise the farmers to go to their maize fields and then cut the crop and take hold of the chaffed crop, and then they can start making a ball out of it using their fist, or they can grab and then make in a fist. They start making the ball of these green fodder, and then if the water is easily squeezing out and material is holding its shape, that is, the ball is being retained, so that means the moisture content is nearly more than 80%. So this is not the stage. And if the water can just be squeezed out and the material holds shape, the moisture content is assumed to be 75 to 80%. But if there is no water being squeezed but the material holds the shape, the moisture content is 60 to 70 to 75%. And if no water is squeezed out but material is also not able to hold its shape, then the moisture content is 60 to 70%. And if again no water is squeezing and the material falls apart very rapidly, so that at that time, that means the moisture level is more than 60%. So these are the two stages when we can utilize for the silage making, and we can make the farmers understand how to assess their crop for the best dry matter content or the moisture level for the silage making. So technically, to understand that, we have understood that what silo is, what silage is, which type of crops we are going to utilize, when is the time to harvest these crops. So technically, we should understand that during this ensiling, what is going to occur, what are the process is going to occur, and how we are going to tell the farmers about these ensiling steps. So for this, we know we should first select the crops which we want to ensile. Basically, we already discussed that these are the cereal fodders, and which are best. And among those cereal fodders also, it is the maize which is best suited for the silage making. And the crop which is suitable for the silage making, let's suppose it's maize, is first chopped so as to increase the surface area to about 2 to 4 centimeter length, and it should have a diameter content of nearly 30 to 35% diameter. So the first step is that we have to harvest the crop. Then we need to first chop it to the size of about 2 to 4 centimeter length, and it should have a diameter content of nearly 30 to 35%. And then we need to prepare the silo. So this silo, the bottom of this silo should be free from the moisture, and it should be above the water table. So it's better to spread a layer of a hay or a straw at the base of the silo, so as that whether if there is any seepage of the effluents, or if there is any capillary movement of the moisture from soil into the silo, so there is a layer of a straw which is acting as an adsorbent, so that it is able to absorb all those extra moisture from the crop, or that is coming from the soil or from the seepage of the effluents. Then we can also utilize some of the additives in the silage preparation, like as molasses. Molasses, it is a readily fermentable carbohydrate source. So at the rate of 3 to 5%, these additives can be added to enhance the content of the soluble carbohydrates, so that there is a better bacterial fermentation and there is a better production of the lactic acid. In order to improve the palatability and the nitrogen content, we can utilize the salt and the urea at the concentration of 0.5 and 1% respectively. And this chaff fodder is evenly spread throughout this silo. This silo can be a pit, can be a trench, can be a bunker, whatever it is. And then it is pressed to expel the maximum air out and trap the minimum air in the silo. So the purpose or the target is to expel maximum amount of the air. So there is a least number of the air pockets inside the material. So for this, we are compacting this, we are pressing it to take out the maximum of the air in from it. This filling of the silo, we are filling it layer by layer, and then we are compressing it properly. But this filling of the silo, it must take very rapidly in the shortest period of the time, because if it is getting delayed, the process of fermentation already starts at the at the bottom layers, and then there is a loss of the diameter with that. So while filling the silo, the ensiling mass, the whole material must be pressed, compacted by the mechanical means, by using tractors or whatever, so as to expel the maximum air out of the silo, because we need to create the anaerobic environment. And after filling that, these silos, they are better covered with the polythene sheets and followed by a layer of a soil or a mud to make it completely airtight. And we should raise the level of the inside mass little above the ground. It is preferred to make a dome shaped, so that if any rainwater is coming and all, so that it can be, because of the slope of the dome, this is taken rapidly out. And because of this layer of the soil or the mud, this will help to, I have also shown in the one of the picture I have seen, you have seen that the layer of, this is the polythene sheet, and this is the layer of the soil or the mud to make it airtight, so that there is no seepage of the water or air from the corners or from any sides of the silo. So, and now we will leave this as such for about 45 days, so that the process of fermentation keep on taking place. And after that 45 days, the silage is assumed to be prepared, and then we need to remove this silage, and can be utilized to feed the animals. But there is a precaution while feeding it to the animals for opening the silage pit or the silage bunker, that it should not be allowed to deteriorate after the silo is opened feeding, because you need to open very minimum phase of the silo, as you will just take out the cover from one side and take the amount of the silage which is required for the daily, and then again after taking the amount, you just need to cover the cover it again very firmly, so that there is no intrusion of the air and the water from that phase. So you don't have to keep it exposed again. So these are the photo galleries of the silage making. These are the bunkers. I told you these are the structures which are created on the ground, above the ground specifically. These are prepared. These are the temporary. These are the permanent structures which we say as a bunker, which we are having in our college. And you see inside this bunker, we are carrying the chaffing process of the green fodder, and this is being chaffed continuously, and then this is being filled, and this is being compressed with the help of the mechanical means like tractor, and then it is covered with the polythene, and then it is properly sealed and airtight with the help of the polythene and the mud or the soil to make it airtight. And these are the one in which these are the temporary silos. This is the plastic containers. This is a silo pack machine through which we are preparing these packs of the silage, utilizing this machinery and the hydraulic pressure which is used to compress the inside material, and from here directly the chaffed material is being taken down to these cylindrical ones in which these polythenes are kept, and then after filling that and after the compaction with the hydraulic machine, we just take out and seal it at one end. This is the prepared silage. This is the silage prepared in the polythene bags and the plastic containers. These are usually the type of a silos which we can suggest to the farmers which are having the small number of the animals. This is the prepared silage was displayed. These are the silage which we are utilizing, which we are preparing utilizing some of the non-conventional feeds also. So now coming to that we have seen how to go for the steps for the silage making. So to understand what is the process going inside. So to understand the ensiling process, let's come with this slide. Fundamentally, the process starts with reducing the oxygen in the ensiled waters, so that there is a increased number of the anaerobic bacteria, specifically the lactic acid bacteria, that need to grow, and that has the ability to convert the plant's photosoluble carbohydrates or the sugars and the starch into the lactic acid, which is a organic acid. And apart with the lactic acid, some amount of the acetic acid and other organic acids are also produced, but we prefer the higher concentration of the lactic acid when these lactic acid bacteria are converting the water-soluble carbohydrates to organic acids. So basically, there are the 4 phases of the silage fermentation. The first phase, we say it is a aerobic phase, because it is the initial phase of the ensiling, and it usually lasts from first 12 hours to 24 hours. So at that time, the material is chaffed. So the plant respiration continues till the time the silo is completely closed. And there are the aerobic organisms present which are respiring, and they are using all the oxygen, and they are converting the carbohydrates of the plant material to the carbon dioxide and the water, and along with the heat energy, which is contributing to the loss of the dry matter. And because of the production of the heat, because of the oxidation of the carbohydrates, the heat is produced, and this will increase the temperature to about 40 to 44 degrees centigrade. And during this aerobic phase, during the first 12 to 24 hours, there is a significant dry matter loss which is occurring in the green fodder. And then but this phase is the primary phase. We cannot skip this phase, and this is the mandatory one. So this is the what we can do, that we just can minimize this phase, but we cannot skip this phase. So here you can understand all the 4 phases through this diagram, that in this for the day 1, when there is an aerobic phase, these carbohydrates, they are converted to the utilizing this oxygen. These sugars are being oxidized to carbon dioxide, water, and the heat. And this will lead to the increase in the temperature. You can see the temperature increases at this time, and there is a degradation of the protein. And because this oxygen is being utilized, so the concentration of the oxygen decreases, and there is a high concentration of the aerobic bacteria, because this is the aerobic phase and the silo is not yet closed. So there is a high temperature, increased number of the aerobic bacteria, and the pH starts declining from 6 onwards, and there is a decreasing concentration of the oxygen. And in the phase 2, what happens? This sugar is converted to the acetic acid, the other organic acid, and so the population of the acetic acid bacteria increases during the phase 2, and the pH start decreasing because of the production of the acetic acid. During day 3 to day 6, the phase 3 starts, in which there is a conversion of the water soluble carbohydrates to the lactic acid, acetic acid, ethanol, mannitol, and the carbon dioxide. Till this time, the oxygen level, the oxygen in the silos is completely diminished, and there is no other supply of the oxygen also. And from here onwards, from the day 2 onwards, there is an increase in the concentration of the lactic acid bacteria, and which also increases in this in the phase 3, and there is a decrease in the pH from 6 to 4.2. And the phase 4, from the day 7 to 21 days onwards, these sugars, they are being oxidized to lactic acid, acetic acid, ethanol, mannitol, and carbon dioxide. But there is a high concentration of the lactic acid bacteria, leading to the increased concentration of the lactic acid from this conversion from the water soluble carbohydrate, and leading to the maximum decline of the pH to about 4 degrees centigrade. And after this 21 days, this is the storage period, and you can keep the this ensiled mass stable until till the time the silage is exposed to the oxygen. So all the fermentation, all the process that occurs inside this during ensiling, this all finishes off after till the 21 days. And after that, this is a stable phase, or you can say that the storage phase, and this time the quality of the material will remain as such till the time it is again exposed to oxygen. So we have already discussed in that thing that there was a stage 2 in which there was a heterofermentation. You have seen there is a production of the acetic acid, and lesser production of the lactic acid was there. So from 1 glucose, there was a production of the 1 lactic acid along with the ethanol, mannitol, carbon dioxide, and the water. But in the phase 3, we had a homofermentation type of a fermentation, in which from the 1 molecule of glucose, there is a more amount of the lactic acid production. So there is a increased number of lactic acid bacteria. You have also seen in this diagram in the day 3, there is an increased concentration of the lactic acid bacteria, and because of the homofermentation, the sugar and the water soluble carbohydrates are converting to the more amount of the lactic acid, organic acid. And the phase 4, you have seen, this was the in which the lactic acid bacteria number have increased to the maximum, and the pH has dropped, and mostly all of the sugar and the starch which was present in the crops is consumed, and the pH has reached to 4. That means the maximum low, and the level in the drop of the pH depends upon the concentration of the fermentable carbohydrate and the moisture of the crop. And then comes the stable phase, when the pH is dropped and the ensiled material is stable, as long as the fodder is again not exposed to the oxygen. The last phase is the feed out phase, when the silage is open for feeding the livestock, and the oxygen accumulation at that time it starts, and gradually with the intrusion of the oxygen and the water, the spoilage starts. So we have seen the types of the fermentation also. That was a lactic acid type, and this is the predominant one is the lactic acid type fermentation, which is a desirable one. But if sometimes when the fodder is not having the high concentration of the water soluble carbohydrates, and the fodder is rich in the protein, at that time the fermentation type usually shifts to the butyric acid type of a fermentation, and this is usually not preferred, because the good silage should not have the high concentration of the butyric acid. Instead, we need the high concentration of a lactic acid in the good silage. The Clostridia are the principal anaerobic microbes that are considered detrimental to the silage quality. And these Clostridia, they can be saccharolytic. They produce the butyric acid, carbon dioxide, and hydrogen. And these Clostridia, they can be proteolytic also, that acts on the protein and produces the ammonia and the amines, that reduces the that inhibits the reduction of the pH. And at that time, the silage prepared is having the high amount of the high pH content. So if there is a proteolytic Clostridial infestation and there is a proteolytic fermentation, at that time there will be the higher ammonia concentration and the pH will not be much towards the acidic side, it will be towards the basic side. And based on the sugar metabolism, we had homofermentative and the heterofermentative. Among these two, heterofermentative is less efficient, whereas homofermentative is more efficient in terms of the lactic acid, because you have seen that during the homofermentative type of a fermentation, the one glucose molecule is able to produce two molecules of the lactic acid. So these are the fermentation. If it is a homolactic fermentation, substrate is glucose, microbes are lactic acid plantarum, then the end products will be the more amount of the lactic acid. And if there is a more amount of the lactic acid, pH will be low. But if it is a heterolactic fermentation, there is a lesser amount of the lactic acid and there will be the moderate pH. So nutrient losses will be moderate. But if there is a secondary fermentation or Clostridial fermentation has taken place, so this Clostridial fermentation, it will act, the lactic acid will act as a substrate for them, and the primary microbes doing so will be the Clostridia, and there will be the production of butyric acid and carbon dioxide, and this will lead to high pH. So if there is any silage or the sample of a silage which is having a high pH, then there is a possibility that there is a secondary fermentation has taken place, and there is the microbes are there is an increased number of the Clostridia microbes, and there is a high nutrient loss has occurred in that silage. And if it is an aerobic spoilage, that means that because of the intrusion of the air, so these yeast and the molds will be there, and the nutrient losses will be very high. Now coming to the silage quality, we have seen how to prepare the silage, what is the process of the fermentation, and now we can see how to assess the quality of the silage. So silage quality, is determined by the mainly we evaluate it on the basis of the sensory evaluation also. Like first we see the color, the smell, or the physical texture of the silage, and then along with that we also go for the laboratory evaluation. In that we basically see the pH, the ammonia, nitrogen, the amount of the volatile organic acids, and the amount, specifically the amount of the lactic acid bacteria in those samples. So the silage quality parameters, it should have the pH ranging from 3.5 to 4.2. It should have a dry matter from 30 to 35%. The protein content should be 7 to 9%. Ammonia, nitrogen should be less than 10%. Lactic acid should be above 4%. Acetic acid should be up to only 5%, and butyric acid should be very less than 0.2%. So these are the parameters that give you the fair quality of the silage. So how to we can go for the quality determinants of the silage. If there is a high moisture, that means if the crop is having a high moisture or the silage prepared is having a high moisture, that means there is excess loss of dry matter through the high effluents. And if there is a low moisture is there, that means the fermentation process was carried very slowly. And about the water soluble carbohydrates, that means ideally it should have nearly 2 to 3% on the fresh basis, and 8 to 10% of the water soluble carbohydrates on the dry matter basis should be there in the material that is we are going to ensile. If there are high fiber, of course, there will be the more amount of the lignin, there will be the decreased digestibility, intake will be less, and if there is a lesser intake, lesser digestibility, the production will hamper. And so the optimum NDF content should be nearly 35 to 55%, ADF 20 to 33%, and ADL, that is the acid detergent lignin, should be 2.8 to 4.1%. And the crude protein should have 7 to 9% CP is optimum for the silage making. The pH, it indicates the silage fermentation quality for the silage. seeing the optimum pH of the silage should be nearly 3.8 to 4.3. But if your silage sample is showing the high pH, that means we can have some of the indications that that either there is a high dry matter content, or there is a poor fermentation has occurred, there is a high protein content in your in your material, or there is an excess production of the ammonia, or there is a growth of the Clostridia that has taken the secondary fermentation, and there is a proteolytic degradation, and there is a excess production of the ammonia, due to which the pH of the sample is high. And if there is a low pH usually says that there is a low intake of the silage. Buffering capacity, you know that the buffering capacity of the leguminous crops is high, and it depends upon the protein and the mineral content of the fodder, the contents of the organic acid and its salt. So we used to say that the mineral that the material which we are preferring for the silage making should have the low protein and the low mineral contents, and should have the low buffering capacity. The ammonia nitrogen, it is the best indicator for the silage fermentation quality. If there is a high ammonia nitrogen, that is indicating that there is a somehow there is a secondary fermentation has taken place. There is a degradation of the proteins. Because of those degradation of the proteins, there is a production of the ammonia, because of which there will be the slow drop in pH, or it can be because of the clostridial action. It also indicates poor utilization of the silage nitrogen due to the rapid degradation of the nitrogen in the lumen. If the high butyric acid is there, we can again think that there can be a clostridial fermentation. And if it is a high acetic acid is there in your samples, that means the silage can have the high moisture content, or during that means they are the loose packaging is there. So sometimes there is a risk for the clostridial fermentations. Clostridia are more prone to growth when there is a high moisture, when the forage harvested is having the low dry matter, when there is a high amount of soil or ash, or that is harvested with the fodders. There is poor packing, or there's intrusion of the oxygen is there, when the number of the lactic acid bacteria is less, when the water soluble carbohydrate content of the crop is less. There are the wet pockets inside the ensiled material that are prone for the clostridial fermentation. This all will lead to the secondary fermentation or the clostridial fermentation. And if there is a clostridial fermentation is there, so there is a great quantity of the nutrient lost. There is a reduced feed efficiency. Dry matter intake will be reduced, and because of that, there will be the lesser production. And these Clostridia, they can break down the proteins, leading to significant loss of the silage quality. And there is also production of some of the biogenic amines like histamines and cadaverine that can affect the herd health and the production, and also can produce some unpleasant odors. So we have seen those were the laboratory evaluations, and because some of the physical evaluation or the sensory evaluation are also important to predict the quality of the silage. With that, we can see if there's a very dark olive green of the silage that is prepared, that means there is a less amount of the water soluble carbohydrate was present. This signifies that there was poor fermentation has occurred in your silage. And if it is light green to green brown, this is the normal color ranges for the grass, cereals, and the maize silage. This is the one color we used to prefer, that is a very light green to green or the golden green color. And if it is pale green or a straw yellow, this will be the normal color range if your substrate is a grasses. But if it is a dark brown type of a color is coming of the silage, so that means there is a aerobic spoilage has taken place, or there is a overheating, compaction was less, loose packing was there, the sealing was delayed, because of which we can say that the color of the prepared silage is dark brown. And odor evaluation, if it is showing you the smell of the vinegar, then you can predict that there can be the high concentration of the acetic acid. And if it is a high acetic acid, that means the silage was not well packed, or it was losing the compaction. If it is having some alcoholic smell, so that there is a production of the ethanol is there, or the yeast fermentation is there. So, and if it is having a sweet smell, So that means there are some amount of propionic acid is there, which we consider as a satisfactory for the silage prepared. If it is a rancid smell, that means there is a butyric acid concentration is high, and that means which is usually because of the Clostridium or the poor fermentation. If it is mild, pleasant, or the natural yogurt smell is there, it is because of the lactic acid. That means the lactic acid concentration is high, which is the preferred one. And if it is a tobacco smell or a caramel type of a smell, that means because of the excess heat production, there is a damage in the quality of the silage. These are the silage qualities, parameters, which we need to follow that. And we have already discussed this ones. And as per the Shepherd, he has classified silage into some of the categories. That is a very good silage, and the fair silage. Very good silage is usually having the acidic taste and the odor. It should not have the butyric acid. It should not have any molds, yeast, or it should not have the slimy texture. And the pH range should be 3.5 to 4.2. The ammonical nitrogen should be less than 10% of the total nitrogen, and the lactic acid should be 1 to 2%. If it is a good silage, then there can be some traces of the butyric acid, but not more than 0.2%. And the pH is 4.2 to 4.5%. The range of the ammonical nitrogen can be 10 to 15% of the total nitrogen. But if it is a fair silage, then you can assume that the pH is more than 4.8. There are chances of slight proteolysis, and the concentration of ammonical nitrogen is more than or about 20% of the total nitrogen, and there are production of the butyric acid and some amount of the yeast and the molds. You know that if there is aerobic deterioration has taken place, yeast are generally the initiators of that. They consume the sugars and the fermentation acids, and they raise the temperature of the silage also, and also they are also causing the high pH. And with the increased pH, bacilli and the other aerobic bacteria, the environment for those aerobic bacteria become conducive, and they start growing, which again increases the temperature more. And finally, these molds and the silage, they completely deteriorate the silage quality. If we figure out the undesirable microbes in the silage, they are usually the Clostridia, and they can be saccharolytic Clostridium also, or proteolytic. If they are a saccharolytic, there will be the high concentration of the butyric acid, and they will be ferment the lactic acid as well as the water soluble carbohydrate to the butyric acid, resulting in the rising the pH. But if it is a proteolytic Clostridia, they will ferment the amino acid to acetic acid and the butyric acid, producing more of the amines and the ammonia, and the growth of the Clostridia is severely restricted if the diameter content of the ensyl material is above 30%. Usually there are some losses during the ensyling. Some losses occurs in the field level, that is when we are harvesting the crops and all, that we say as a pre-ensyling losses. And some losses, I told you that during the first 1 day or 12 to 24 hours, there is an aerobic phase, at the time when there is a oxidation of the available water soluble carbohydrates with the help of the oxygen, and there is a production of the carbon dioxide, water, and the heat, that is leading to the loss of the dry matter. That is the loss during the ensyling, and because of the oxidation. And there is a certain effluent loss which also lead to loss of the dry matter. These are the losses which occurs during the ensyling. Thank you.
क्या मैडम हो गया?
जी डॉक्टर साहब.
हो गया मैडम?
जी डॉक्टर साहब.
Okay, thank you very much. If anyone have any query, please write in the chat box or may directly ask to the madam.